welcome to another class. We are going to continue with differentiation, and we are going to look at the stationary points. And in stationary points, these are points where the gradient of a curve is equals to 0. So you're going to look at different cases where you have the gradient equals to 0. Number one, we have a curve that is y is equals to x squared plus 2x plus 3. We sketch it, we see the behavior of that curve about the stationary point. So the first thing to do is to get the derivative, the gradient function. d over dx will be, we drop the power, get 2x, then 2 minus 1, we get 1. Then for the 2x, you get, that is per 1. Drop that power, you get just 2 times 1 is 2. Then x minus 1 minus 1 is 0. So that is our derivative of that function. Now, that is the gradient function. So we want to know at a stationary point the gradient is 0. So our gradient function here we equate to 0. 2x plus 2 is equals to 0, and you're going to have 2x is equals to, we take plus 2 on the other side of the equal sign, you get minus 2, and then x will be minus 2 divided by positive 2, you get minus 1. So that is where we have the stationary point at x is equals to minus 1. Now, to get the coordinate of the stationary point, we need to use the equation of the curve. Y is equals to x squared plus 2x plus 3. We replace the values of x with minus 1. So you can have minus 1 squared plus 2 times minus 1 plus 3. This you're going to get minus 1 squared is positive 1 plus 2 times minus 1 is minus 2, then plus 3. So you have 1 plus 3 is 4, then minus 2, you get minus 2. So at stationary point, the coordinate is x is minus 1, y is positive 2. So that is our stationary point. Then we need to know the nature of this stationary point, how at the stationary point on the right and on the left hand side of the stationary point, how is the gradient changing? So we are going to make a table, and this table we are going to have the x values and then the gradient. So we have at stationary point is at x is minus 1. Then we are going to look at on the left hand side of the stationary point, how is the gradient behaving, and on the right hand side of the stationary point, how is the gradient behaving. So you can have maybe minus 2 here, and then on the right hand side you can have 0 and maybe 1. So our gradient function we have as gradient is equals to 2x plus 2. That is our gradient function, our derivative. So we substitute these values. So at minus 1, the gradient is 0. So we want to see at the left hand side of the stationary point, how is the gradient. So you're going to have 2 multiplied by minus 2, then plus 2. You're going to have minus 2 times minus 2 is minus 4 plus 2, you get minus 2. So at the left hand side of the stationary point is minus 2. Then you can look at on the right hand side, you can use the value 0 there. So 2x plus 2, we replace x with 0 times 0 plus 2, we get 0 plus 2 is 2. So this is 2. And use even at x is 1, is on the right hand side of the negative 1. So you can have 2 times plus 1, then we add 2, replacing that gradient function, you get 2 plus 2, you get 4. So that is our gradient on the right and on the left hand side of the stationary point. So what you're going to consider is the sign of that gradient. Now, when we look at our gradient, on the left hand side of the negative 1, the gradient is negative, then 0, and then on the right hand side of minus 1, where you have the stationary point, the gradient is positive. So, gradient being negative, now for us to be able to sketch the negative represented like that. That is how the negative gradient behaves. Then 0, that is 0. Then positive, we represent it like that. So that is the behavior of the curve. Negative, then 0, then turns the other side as positive. So when you go to now the sketching, you can just have a simple representation there. So we have the stationary point is at minus 1, 2. So at minus 1, 2, that is where we are having the stationary point. The gradient of this curve is 0. So on the left hand side of this point, the gradient is negative. So that is the behavior of the curve. Then on the right hand side is positive. So the curve starts on this side, then goes like that. So this is negative, at this point is 0, and this side is positive. So that's how you can be able to sketch for that particular curve. So you can see the behavior, negative, 0, then positive. So at this point, minus 1, 2, the gradient turns from left to right as negative, then 0, then on the right hand side positive. That this point is known as, or this particular stationary point is called the minimum point. This is the lowest point that that particular curve can go. This other side can take higher values, but this is the lowest point at minus 1, 2. So this point is referred to as minimum point. So let's look at case number 2. We sketch the curve y is equals to minus x squared plus 4x minus 2. We want to see the behavior of the stationary point where the gradient is 0. So the first thing to get here is the gradient function. We get the derivative of this function. So this is going to be equals to rid of this power. We're going to be having minus 2x power 1, then plus 4. That is our derivative. Then we equate our gradient to 0 because at stationary point the gradient is 0. So minus 2x plus 4 is equals to 0. Then minus 2x is equals to, take my plus 4 on the other side, we're going to get as minus 4. So divided by minus 2 on both sides, and we are going to have as our x equals to minus 4 divided by minus 2 is positive 2. So where the curve has the gradient as 0 at the stationary point, the values of x is equals to 2. Now we also need to get the value of y so that we can be able to know the coordinate at which the stationary point is. So we take our equation of the curve, y is equals to minus x squared plus 4x plus 2. We equate the values of x with 2, so we get minus 2 squared plus 4 times 2, then plus 2. So this is going to be 2 squared is 4, then minus, we get minus 4 plus 4 times 2 is 8 plus 2. So this is 10 minus 4, you get 6. So where you have the stationary point, the point is x is 2 and y is 6. So that point is 2, 6. So that is our stationary point is at 2, 6. So we want to see the behavior of the curve around the stationary point. So you're going to look at the gradient on the left hand side and on the gradient on the right hand side of the stationary point. So we are going to make a table where we have our x and then the gradient. So can have two values there at point 2, and is where you have the stationary point, and then can have 2 points on the right and 2 points on the left hand side of the stationary point. So you can have 3 and 4. In this case, you can have 1 and 0. You check the measure of this gradient. So at point x is equals to 2, the gradient is 0. So you can have where the x is equals to 1, we see how is the gradient. Our gradient function is minus 2x plus 4. So you replace x with 1, get minus 2 times 1 plus 4. You get this is going to be minus 2 plus 4, get us minus plus 2. So the gradient is 2. Then when x is equal to 0, we are having minus 2x plus 4. We replace x with 0, then plus 4. 2 times 0 is 0, plus 4. So the gradient is positive 4. Then for the case where x is equal to 3, we're going to have minus 2x plus 4. So minus 2 times 3, then plus 4. Get minus 2 times 3 is minus 6, plus 4, get minus 2. And lastly, can have the point x is equals to 4. Get the gradient there, minus 2x plus 4, minus 2 times 4, plus 4. Minus 2 times 4, you get minus 8 plus 4. And that is going to give us minus 4. So that is our nature of the gradient on the right and the left hand side of our stationary point. So this is our stationary point. So on the left hand side, the gradient is positive. And then on the right hand side of the stationary point, the gradient is minus. You have minus 2 and minus 4. So when we sketch that, the positive gradient of course behaves like that. Then the negative, there's 0, straight line, horizontal line. Then the negative behaves like that. So that is negative. So that is our nature of the curve. And then if you can sketch that, we have the coordinate 2, 6 as our stationary point where it is. So we can have a small representation here. So 2, 6. So at 2, 6. So this is where we have the stationary point. So on the left hand side, it's positive. So the curve starting on the lower side up to that point, then gets back and then changes to positive. So this side here, the gradient is positive, and then at the stationary point, gradient is equals to 0. At the right hand side, the gradient is negative. So that is how you can be able to sketch that and be able to see the representation of that particular curve. So one thing that we need to note here is that at this point now, in this case, this is the highest point that our graph can be able to go. So this point is referred to as the maximum. So that is the maximum point, and it's called the maximum point in that curve. So for the case number 1 and case number 2, the maximum and the minimum points, they are referred to as the turning point. So another name that you can give to the stationary point, if it is maximum or the minimum, like the way we had the case number 1, that point is referred to as the turning point. That is where our curve is turning. Like the case number 1, we had negative, then 0, and then positive. So the minimum point, the maximum point are referred to as the turning point. Now let's look at the last case, the case number 3 of the stationary point. And in this case, we want to sketch the curve y is equals to x cubed minus 4. And for us to be able to do this one, the first thing that you need to get is the derivative, that is dy over dx, our gradient function. It's going to be given by, we do the power, you get 3x, then power 3 minus 1, you get squared, then constant will be 0. So this is our derivative of that particular curve. So this is our gradient function, and in a stationary point, the gradient is equals to 0. So if we 3x squared is equals to 0, in this case we divide by 3, we have x squared is equals to 0, and then x is equals to 0. So at the stationary point, in our curve here, the values of x is equals to 0. So can we be able to get the value of y using the function? So y is equals to x cubed minus 4. Now we substitute the values of x. We get from this 0 we have, then cubed minus 4, and this is going to give us minus 4. So where you have the stationary point, the coordinate of that point is 0, our x, and then minus 4, our y. That is why we have the stationary point. So the next thing that you need to get is that you want to see the nature of the gradient on the left-hand side and on the right-hand side of the stationary point. So you're going to make a table, and you can have it here. We have x and then our gradient. So at point 0, that is where you have the stationary point. The gradient is 0. Then you can have 2 points on the right and also 2 points on the left hand side. So on the left hand side of 0, you can have minus 1 and minus 2. On the right hand side, you can have positive maybe 2 and positive 5. So we just want to see the behavior of the gradient on the left hand side and on the right hand side of the stationary point. So at minus 1, our gradient function is given as our derivative here, which is 3x squared. So at x is equals to minus 1, we have 3 times minus 1 squared. This is going to be 3 times minus 1 squared is 1, we get 3. So that is 3. Then at x equals to minus 2, I'm going to have 3 times minus 2 squared, and this is going to be 3 times minus 2 squared is positive 4. So that is 3 times 4, get 12. So that is 12. Then we have positive 2. So we have our gradient function 3x squared. So x is positive 2 squared, that is 3 times 2 squared, that is 3 times 4. And we are going to get us positive 12. And lastly, we have x equals to 5. So 3 times 5 squared, then that's going to give us 3 times 5 squared is 25, and that is going to be 75. So that one is 75. So what you can be able to observe here is that on the left hand side of the stationary point, our gradient is positive, and on the right hand side of the stationary point, the digit is still positive. So if we were to sketch that one, the positive behaves like that. That is the positive representation. Then 0 is a horizontal line, that is 0, gradient, then positive again, like that. So that is how you can be able to have a graphical representation of negative, positive, 0, and then positive. So for us to sketch, we need to have our point where the curve has the digit as 0, that is point 0 minus 4. And have that one, have our sketch. So to sketch our curve, we have on the left hand side of our stationary point, that is at point 0 minus 4, the digit is positive, then 0, and then positive again. So this is how you're going to have it. Positive, of course, good to be from the lower side. So you have that, then 0, and then continues to be positive. So that is our sketch of the curve. That's how the curve behaves. And that kind of a curve, the behavior, this one is different from what we had previously in the first and second case. This kind of a behavior where the gradient turns from negative on the left hand side, 0, and then positive. That point is known as a point of reflection. It is also the same case when the gradient turns from left side to be negative, then 0, and then continues on the left. That is also a point of reflection. So this side is positive on the left hand side of the stationary point, then on the right hand side is still positive. So in that case, this is a point of reflection. So that is how that curve behaves. So those 3 scenarios, those are the cases that you can be able to find for the stationary point. It can be either be a minimum point, a maximum point, or a point of inflection.